Good afternoon, and I'm very happy. I think probably all very ready for weekend, isn't it? You work weekly 5 days, correct? Hello.
No, sir.
Saturday also do you work?
Alternate Saturdays we work.
So, tomorrow is also working day.
Yeah, it's a working day for
So
us.
then probably we could have covered one more subject. But anyhow, I think probably you are not interested. I think probably I will ask Neeraj actually. Anyhow, thank you. So I just before I start this thing, how many of you are having a chartered engineer status from either Institution of Engineers from India or any of the professional bodies like UK? In normally, if you go to USA, they call it as a P engineering, professional engineering. But if you have a Europe and UK, they call it C engineering. That is chartered engineer actually. In India also we have they call it C engineering. How many of you are on that? You got the C engineering or on the process, on the pipeline of to get the C engineering? There are some way path actually. There are some exams and all the things. In India, generally, if you are a member of chartered engineer, if you're a member of Institution of Engineers, generally, after some years, they start with the associate member and member, then after that, they become a fellowship. How many of you are on that line?
We have an IMAKI certificate, so that's a basic for chartered engineer of UK sector. So we are actually in the process of getting IMAKI. That needs to be very. And we also have some lead professionals, lead AP certified.
Okay, very good, very good. So in fact, okay, that's right, that's nice, very nice. So IMAC basically, I was basically the ambassador of IMAC to promote mechanical engineering, particularly in Oman, among the school children. And IMAC is, but I was a member of IMAC. Then later stage, I specialized in since the building services. Okay. There is another institution called as Chartered Institution of Building Service Engineers. So that way, both the way I become a chartered engineer. Okay, since you are an IMAC, I think IMAC has got very active in India.
That's a SIPSI UK, no? SIPSI UK.
Yeah, SIPSI UK, yeah, Chartered Institution of Building Service Engineers in that, yes. Because mostly IMAC, a lot of people, they are no core mechanical engineering, like who work in oil industries and the turbines and they building services normally very as a specialized this SIPS is normally they do, and they have a lot of interaction with ASHRAE also. And how many of you are a member of ASHRAE? Everybody?
In Jaipur, 5 of our team members have got ASHRAE certification. ASHRAE membership. We can answer better for Durgapur.
Okay.
No, actually, Kiran is a member of ASHRAE, so I've seen that.
Yeah.
Okay, that's right. Very nice. Yeah. So do you people normally conduct this type of continuing professional development educations regularly to among yourself to update your, like, of course, this is a part of the training, external training, but
we do, sir.
Among yourself, interdepartmental continuing professional development, normally do you carry out among within yourself, with your region, within different offices?
CPD score, you understand? CPD
yes,
points.
That's right. Yeah, CPD scores to keep your status normally. I hope this all you are maintaining. Anyhow, I just asked you to find out because many of these type of professional organizations, one advantage to become a member is you may have so much literatures available and the codes are also available. Similarly, ASHRAE, maybe 40 years ago, we don't have this type of professional societies in India, but now only the apex body was Institution of Engineers, Calcutta. But now we have various societies, even ASHRAE is also very actively involved because there's a lot of gap between academics and industry, and this type of professional bodies always try to be a bridge between these two, academic and industries, and they always want to share the case studies, and they help us actually in promoting the standards and collecting the data, and the data is also under go various processes to get the information, and that information will be always used as a standards, and that standard will be used for the design engineers. So it is an evolving process. So that is the reason I asked you all the thing. So let us now start with that. And as I told you, we started the first class quickly. I'll review whatever we have done. This is my habit actually. We started with the sustainable air conditioning system design. We discussed the main focus on that day was air conditioning. We concluded that definitely the conventional air conditioning system is highly energy intensive and it consumes so much of energy. So we should always look for the alternative technologies. And then plus in the refrigeration side, plus as well as various design aspects also, we should look into the air distribution side and air handling units like that. Then we focused on the specialized hospital air conditioning system design, because why we have taken hospital air conditioning is a very specialized system design air conditioning, though it is one among the process air conditioning system, but hospital has got a various stringent control measures. So that is the reason we focus on the hospital air conditioning system design. We also start talking about. And then we have, in fact, indoor air quality and hospital air conditioning is more or less complementary to each other. So we focused on indoor air quality, and then ASHRAE standard 62 we focused. And yesterday we had a good discussion with Professor Dr. Riyad also. We also put various kinds of filtration, various kinds of duct design, and how we can eliminate and all the things. So now today's class will focus on the energy conservation, and we will focus on the code of ASHRAE 90 for energy efficiency in that. As always, I told also, energy saved is energy created. So particularly as an engineer, we have a lot of responsibilities on our shoulder, particularly the HVAC engineer. Since the conventional air conditioning system is highly energy intensive, whatever, even a fraction of the kilowatt or what we are going to design at the various stages, whether it may be a design of the product or design of the system, definitely will always help us to have this environmental impact. Because I also very briefly discussed in the first class about the climate changes is a very serious issue. We have different kind of international protocols, even I think recently India also signed this Kigali agreement of the part of Montreal Protocol very few days ago. I understand Cabinet has given the approval. That is one of the happiest news to talk about this. Kigali agreement is related with the hydrofluorocarbons, HFCs actually. And it's a part of, again, Montreal Protocol. And the COP in India is also leading now. So that way, energy as a part of energy saving is a lot of responsibilities to avoid this climate damages. Actually, what we have done so far, we want that our next generation should live peacefully in this planet Earth. Actually, in that. This is I thought that probably before I start any lecture, I also want to start with some statistics. This everybody knows that maybe from part of wealth or part of energy also. If you see the world population, we have two kinds: developed countries and developing countries. And most of the population is highly densities in developing countries, and very less population is less in developed countries. At the same time, that developed countries, that is 20%, they use 60% of the energy, whatever the world energy is consuming. So that is what probably here what the conflict comes. So you may ask, sir, is there any correlation between developed and the energy consumption? I hope the point what I'm coming to say, that because they are using 60%, and because of that, it's a developed country, and we are not using energy because that's what we are developing countries or underdeveloped countries. So for that purpose, only this slide I have given. And even I remember in 1980s when Montreal Protocol wanted to implement in the United Nations Environment Program, when America wanted to stop this ban this chlorofluorocarbons, CFCs, India has strongly objected because it's even those days India refrigeration and air conditioning was a luxurious, whereas in this type of countries, this part of the world, particularly Europe and developed countries, refrigeration and air conditioning is a part and parcel of their life. So they consume huge amount of quantity of refrigerants. And then initially they were reluctant to sign in the protocols. But the latest stage, these developed countries have assured them, we will give so much fund to do all this fundamental research. On that basis, only India signed. Later, China also is involved in that. So that is a part. Montreal Protocol was one of the successful international protocol so far has been implemented to control these ozone depletion substances. So, as I told you, the index, the developed countries. So we have different kind of indexes for the quality of life. So that's what probably they use so much energy in that. So that is what the link actually. So most of this energy, what we produce in the world, it's used by the developed countries. And energy conservation and energy efficiency are definitely separate, but they are complementary to each other. So energy conservation is basically achieved when growth of energy consumption is reduced, and then it should be measured in the physical terms. So it is basically, it consists of various processes like from the starting from the productivity. I mean, in my first class, I also told, like whenever we designed this type of air conditioners, how we started using COP, the latest stage we called it the energy efficiency ratio. Then we started seasonal energy efficiency ratio, various factors. So then we also try to design. For example, now, whenever I do design calculations, like I showed the major companies like Carrier, Train, and McAway, York, when I, as a thumb rule, when I do some energy, whenever I'm doing analysis of the tenders, when they submit their code, particularly central chillers, water-cooled chillers or air-cooled chillers, we always have some benchmark, this much horsepower, or this much kilowatt per tonnage. So there also we have given some weightage when we do analysis for our tender KPI points. Actually, we give, in fact, more weightages for that. Even our capital cost slightly maybe more, but still we prefer any company who offer the better chiller with the less energy ratings in that. So whereas the energy efficiency is achieved, the energy intensity specific product is what I'm telling, the process or area of production or the consumption is reduced without affecting the quality. That is very important. Whenever I'm doing, I think that's what I was telling. I was referring. I did a study about 3-4 years ago, different kind of buildings in Oman. Like I've done one prayer hall, mosque here, the Grand Mall, and then one of the hospital, and then one office building, and then one hotel industry. So 4 different different applications. So I have also collected the data, and then I have done, and a very big report I have prepared, interim report and final report, both I have done actually. So that also, if I get the paper, I will share it with you that. So when we go for energy conservation, I said energy saved is energy generated. So when we have energy efficiency, these are some of the advantages. You know that we definitely, we in India, we have really gone in very advanced in various levels. We have different kind of institutions like Energy Efficiency Bureau and renewable energy, so many institutions are there, and they are doing even IS Bureau of Indian Standards. They also work very closely, and they also created so much standards. And for the last 4 decades in that, very much advanced they have done. And USA definitely, they are the leader in all these things. And but particularly in this part of the world, in Middle East country, necessity is the mother of the invention. Maybe 20 years ago, 30 years ago, that concept was not there because nobody is having a data, and energy is very cheap here. And because most of oil is produced in this. The entire world economy is based on the oil, actually. So almost all the power plants are basically oil-based only, not like India, where we have a coal-based thermal power plants, or because we have a coal is available. Like if you go to the developed countries, we have a lot of nuclear energy. In India also we have, but nuclear energy's contribution is maybe not that much significant, maybe 9% or 10% or 15%. And we also have the renewable energy like wind energy and all the things. So 25 years ago, this was not there in this type of GCC countries, particularly in Middle East. But now, because of all this international environmental protocol, where they are also signatories, all this type of international protocols, even COP, most of these countries they sign, they have a commitment to reduce this carbon releases, actually carbon monoxide, and they also don't have much clean energy, like they don't have a hydraulic power stations, because we don't have much dams and all the things here, not like India, or maybe in Canada, or where we have so much hydraulic power stations are there. And so that's what they always try to improve upon this type of, one is from the source product side, and second is again using the renewable energy to reduce this type of carbon reductions as well as carbon rating, because they must have some commitment within this much years. Every government has got a different protocol they must have signed. There is a separate department. That's what, on that basis only, UAE have developed a separate institution called as MASDAR. And they do so much research. On that basis only, the Stadama, the standard they've been developed, they have developed actually. That has become as a reference now to all this type of thing in that. So these are many energy efficiency benefits, basically. And I hope this you all may be understanding this energy unit intensity. Because this is normally as a benchmark based on the data normally. Every country has got its own different kind of energy unit intensity, with different type of buildings differs, because you have a different type of lux level in a hospital, production level, you have different type of lux level. And similarly, when you go for air conditioning, inside comfort also different kind of comfort requirements when you design. For hospital, we have different inside condition. Maybe when you go for a product factory design, so probably you can go for a higher temperature, maybe 27, 28 is also okay. Even it can go up to 30 degrees. Or in some places you don't need air conditioning, probably you need only evaporative cooling, just like textile industries, spinning mills and weaving mills. So this type of thing, everything in that. So on that basis, every building has got a different envelope and different working hours. We have occupancy rates and different kind of HVAC loads, and we have different kind of light loads. Then, of course, water consumption and fuel consumption. So for that purpose, normally they try to have some benchmark called as energy utility index. That's the unit is kilowatt hour per meter squared. And then that one I have just normally I have taken. They are important factors and contribute to the performance of the building in that. So this generally I have taken from Singapore energy and utility index. I have taken from that, because when I was doing my study here in Oman, we don't have this type of energy utility index data here, and still we are struggling. And because we don't have data, people are not understanding. But probably now we have also a professional institution called as Oman Society of Engineers. So they are also very seriously looking for to collect this type of data to find out. So these are some of the average energy intensity for the various kinds of buildings, hospitals, offices, supermarkets, hotels, schools, and small clinics in that. So, and also this all, maybe you may be also considering when you do the include calculation or when you do the energy efficiency design. We call this cooling degree days as well as heating degree days, HDD, and this one. So this I'm talking about in Muscat, the CDD actually, cooling degree days actually. But mostly when you do in Europe or something, we always take the this all data. So you can take it from the metrological design values. This must be in the standard also. So basically, the cooling degree days determine the quantity of energy required to cool your building. It is a measure of how much and how far long in days the outside temperature was above the certain level, just like a benchmark level. They are commonly used in calculations relating to the energy consumption required to cool the buildings in the design aspect. So CD values are used to design the size and capacity of the air conditioning units. So on that basis only this I have taken. So this energy saving, particularly ASHRAE normally as a guidance is ASHRAE standard 90.1 in that. So we have, every country has got different kind of standard, different kinds of codes. And but ASHRAE, again, we all follow ASHRAE 90.1 as well as yes. So this normally applies to the small to medium sized buildings with the floor areas up to about 100,000 square feet area. So basically, if you are able to have to achieve and maintain 50% energy use reduction in any of the buildings, any site, you have a specific set of building energy systems on that by designing. So that should be a target if you really want to design the design stage. So for that basic understanding of the local climate, site requirement, and what are the drivers for the building orientation, and the budget again, the capital cost as well as the recurring cost, and the creativity of the AC design engineer. This I've been telling all the time. A design is a creative issue. It cannot, okay, we have a set of rules, but at the end of the day, how best you are using your creativity, how much the commitment, how much you are putting your heart and soul to define actually, to design a system. When you as an air conditioning system is, it involves various things, like you have to take a product chiller, and there also you have very limited thing because it is coming from different manufacturers, different data sheets are there. Then you have a different kind of material. Then you have to also involve the different kind of stakeholders, various stages. So this is the what your creativity and then your teamwork actually. So this all basically you have to understand, and that is the best factors for the designing on energy efficient system in that. So as I've been all the time, I'm telling you should always go for the integrated design process approach. But if you ask me, sir, when you go for integrated design process approach, will you be able to design 100%? I will tell yes. It is not, I cannot assure. Every system has got its own advantage and disadvantages. That's what I also explained to you. Though we use to execute this airport project here in Oman, all high-level latest softwares for designing, three-dimensional view, three-dimensional analysis. Even in we can always visualize it. Even before the site is before the plain site, how the building looks, what are the services will go, all the services, everything you're able to see the three-dimensional modeling. Everything we did on computers by using a latest advanced software. But during the execution time, we really failed. It failed in the sense the project delayed almost 4 to 5 years because of the quality control issue, various contractors, or maybe there was a lot of communication gap, or it was not documented properly. Various agencies, in the site, various agencies are involved. There will be a main contractor, a civil contractor, and there will be electrical contractor, there will be air conditioning contractor, even electrical air conditioning also, there will be so much subcontractors, which all in the first class I mentioned. For deducting most of the thing, either you are a prefabricated or sometimes you are locally fabricated. And then piping, you may have a different kind of piping contractor. Then you have erection contract. I mean, all the equipments are tested and brought to the site. So this is all with the standard specification, like inspection certificate. You have to also ensure that the same product is delivered and the same product is installed as per the installation manuals. And then all these things again, finally, is it being properly tested? And then it is pre-tested and tested and commissioned and documented. So various stages also there. So definitely energy saving become a very important topic nowadays, everywhere, the whole world. So it definitely, what are the essence, what are the critical need of the energy saving? What we need actually? We need definitely an experienced and innovative design team, as I told also. And then we also need a database, an integrated design process. Based on the integrated design process also, it should be also based on certain benchmark value. And then as much as possible, you need to have a daylighting consultant, because this lighting is also become a very specialized area now. And then lighting consultant as well as air conditioning consultant, they have to work like both brothers actually, because many times all the services, the fittings and everything, if you go on during the execution time, most of these lighting fittings, they are so much advanced now. And then your ducting also, you are taking about the false ceiling, and the architect always give a very, very limited space. So you may have a different difficulties in execution time in the design. You may not anticipate all the thing. So this all you need to avoid. That's what yesterday also I told, the meaning of this risk management. Risk management calculation at the design stage is a must. What type of risk, how much risk factor, and how much it is going to affect during the execution time also. Then energy modeling, every software has got the energy modeling. Then commissioning, we have a commissioning course. Now commissioning is also emerging as a very specialized subject, particularly in air conditioning. HVAC commissioning has become a very different, specialized commissioning, very specialized area now. A big, like district air conditioning in Dubai and all the things, they have a district air cooling system. So in that type of building, we may have 20,000, 50,000 tons of plants. And that type of such a big plant, we need a proper pre-commissioning as well as commissioning, and then testing, and then documentation in that. And then the training of the staffs who are going to maintain that one. And then automation. The automation is also very, very important, particularly the building management system. And though we have a very sophisticated controls nowadays, but all these sensors, now, I still remember in 1988 or something, I was trying to develop a microprocessor control for the railway coach air conditioning system. I remember it was a ASHRAE conference, and I was presenting one paper about the microprocessed controls in the train compartment. That those days we don't have a 3-tier AC; it was a 2-tier AC mostly. The 3-tier AC started coming maybe after 90s only. This may be 88 or 89. I still remember when I was trying to work out on that 2-tier microprocessor based controls. But now this has become a modern BMS system and all the things. That time I was not aware much on that. So when I was making that paper, we have put various sensors. Even I was presenting the paper, the industrial representative, the first question what they asked me was, what is the energy of your sensors? Now I put the various sensors at different places, like supplier duct, I put the humidistat or thermostat, and the sensors will also send the signal. Then it will try to get the analog signal to digital signal. And then how much time it will take, the energy of that one, and how much response time my mechanical equipment will respond, like my compressor or this type of the question. So at that time I was not much clear about that. But let us take the practice, and when we work on the system, when we see, and there's so much advances later it has come, particularly on the building automation system, building management system. The building management system is definitely a very, very important. It's a part and parcel of HVAC system design. I hope you all strongly, or you are recommending BMS system when you are designing your HVAC system, for any, irrespective of whether it is a smaller system or bigger system. I hope that automation system in association with to monitor your air conditioning system, I strongly recommend that you should always recommend the BMS system. I hope you are you doing. I'm just asking. Like for example, you are designing a hotel project, let us say 300-room hotel project. Are we recommending the BMS system? Or if you are designing a hospital, about say 200-bed hospital or 300-bed hospital, are you recommending BMS system as a part of your HVAC system? Hello?
Yes, sir. Actually, the whatever project I've been working on.
Okay. So you have the.
In most of those, the engineer of record, they had already mentioned that they are going to use the BMS system. So yes, we understand the importance of that, and in case we design it from scratch, we always go with that.
Okay, that's right. That's what that should be also a very important point, because this BMS definitely will help us not only on the design stage, even during the operational stage also, operation time also. The O&M contractor, who are operating and maintaining the contractor, will also, they can use it, this BMS system for the logging the data, and then latest for the energy study, then it will be useful also to carry out the energy auditing. Because energy auditing is another subject which is a part of the maintenance contractor or facilities management contractor in that. And the air conditioning industry is growing, exponentially growing actually. The whole, this was the only flourishing industry, irrespective of the very downturn everywhere. Every irrespective because the climate is also very harsh and people are manufacturing everywhere, whether it's a unitary type of air conditioners or package air conditioners or central air conditioning, and they don't have a time. That's what jokingly or sarcastically I mentioned all these leading manufacturers. Probably you people don't use much R&D in the development of our refrigeration product. I don't know if I'm wrong, you can correct me. You know how much we have done in automobile engineering, how much R&D we have done. I'm just asking, like, for example, a car about 50 years ago back, and how much advanced car, like if you go to the Benz or BMW, everything, the safety, not only this, we have also done, but comparatively, compared to the IC engine design improvement, the controls, even the embedded part actually, relatively what we have done in our refrigeration equipment, people will tell, okay, sir, we have done so much advancement design in compressor or heat exchanger. We have done a lot of things in micro channel heat, many things we can do. But to me, my personal opinion, we have not done much what the automobile industries have done in that. And because we are also very energy intensive also, actually. This is what my personal opinion, but if I'm wrong, you can correct me. So whenever the platforms, whenever the opportunities I get, I always tell all these major manufacturers like Carrier, ASHRAE, Carrier and Train, and this York, Macway people when they are there, even Johnson Controls, and all this type of leading manufacturers, Daikin also, the leading manufacturers when they come actually. So that's what every government has always taken a lot of initiatives to develop energy efficient air conditioning system. This also in my first class I told, most of the governments from the source itself, they will specify there's energy star ratings, energy. If you see about 50 years ago, very few companies in India who manufactures air conditioners. There was a Delhi-based company called as Fides Loye. And then this Voltas and Blue Star, these are the three leading companies, maybe 40 years ago. And they were mainly focusing on window type of air conditioners. And then maybe Voltas and Blue Star also, they normally get it assembled from somewhere else. They put their their name in that. But Fides Loye, they have a very big factory in somewhere in Delhi, Bugla, and they started manufacturing. And but those days, as I told you, air conditioning was a luxurious, but now it has become a part and parcel of our life to everybody in that. So the government always put various initiatives to adopt the energy efficient system. They also introduced the star ratings, and they also so that if you don't have this much star, you cannot be come into the market, because a common man may not be knowing all the thing in that. So this is what I was telling on that day, this Oak Ridge National Laboratory, ORNL. And they are basically, it's a very good research laboratory based in US. And they do a lot of research study. Even they also develop a lot of modeling. Last time also, I told that I have used their heat pump model, which they developed probably 30, 40 years ago for my simulation of some of my air conditioning system, maybe 30 years ago. And it was, most of the source code was written on Fortran actually. And so they are also concluding that smart air, everybody is always trying to go for a smart HVAC system. And they also conclude that improving air conditioning efficiency could avoid almost 100 billion tons of carbon dioxide. So this is what the leading air conditioning engineers should invest more on their R&D. This is my personal conclusion in that. So if you see the traditional design process as a design stage, we have architect, the owner is there, architect directly relate with the owner, because And then we have contractors, we have engineers, then there are cost consultants, and then we have specialists like various specialists in lighting. We coming like this HVAC, acoustic, fire, security, communication, energy, commissioning, all this type of specialists will be there. So this is normally a traditional design process. Now, when I talk about the integrated design process, we need to have a design team leader with a certain target value. And then every time, the hierarchy, this is called as integrated design process. So the communication is everybody knows what they are doing actually. So this is the advantage of the integrated design process. And the key design activities for energy efficiency, this is a thing probably you may be also doing, but still just for a line diagram. First, the kick off the concept of the design, identify your design goals actually, then do some brainstorming sessions to understand the zoning and all the things in that. Then schematic design, when you go for the schematic design, come up with alternative routes. And then when you go to the development, lot of analysis when you do cost analysis, and then doing the documentation, design documentation, and then all these team members, you present it, make them to understand, because you bring them to your level, and every time you review it, all the various stages, and then it should be feedback also. This is a flow diagram which you may be doing also, but in the design activities, you have to do all these things in there. So when you do in the concept side, this is what I have shown in the figure, the status of the site conditions. As much as possible, these are some of the part will be useful by an architect. As much as possible, use the natural resources. Like even when you design your air conditioning, find as much as data like sun, wind, the orientation of the building in that, and low availability of the local materials. And as much as possible, you also try to use this reused material. And then particularly about the, if you have a documentation regarding the utilities available there already, and surrounding buildings, what are the conditions, what type of code they used, what type of regulations, local regulations they have. And this all you have to have at the design stage itself. You may be in your having library also. Landscaping of the heat island as much as possible. The landscaping consultant who always now even people always try to come the roof gardening. So they always feel that, so that will definitely give so much shading effect. The shading effect is another important aspect when you do your heat load calculations. Similarly, all these site sustainability opportunities when you are going for a LEED certification or your local green building certification. So these all definitely to be considered. It will definitely encourage to get the energy saving in that. So when we in the design, schematic design itself, as much as possible, put now you have advanced softwares, put these various outdoor design conditions and find out this local this thing, and then as an interdisciplinary measures, you interact with your other counterparts, and then particularly this architect, like I was doing is Oman Museum here. It is one of the iconic building. It took almost 4 years, but the design stage itself, it took almost 1.5 years. We have various architects, various consultants from different parts of the world, because this is a very specialized museum, and 400 million real just to be completed. Commissioning is going on. It is almost 300 kilometers away from Muscat, and it is a very dry area. It's not like Muscat is very near to the coast area, but this is a mountain area actually, and very like a desert actually. So even there was an idea, because so much places we have to use so much fresh air. So we thought that why can't we use the evaporative cooling system? Some areas, this interesting because the architects are from Australia, and then we have a process consultant from USA. And being a museum, we also have a specialized, because almost 1,000 years old back history, we have to bring it. So it was very interesting design process. So on that time, initially we thought that we should go for a lead building. Really, we wanted, but all that all we include. But later stage again, we because of the fees and then so much points we could not square it. I mean, even for example, we want to use this recycled water, like we call a sewage treatment plant. The water which we use, we want to put the recycling plant, and then we want to reuse it for the landscaping, which normally we use in India, everywhere we use. But here the protocol, particularly the royal family, they have something psychological concept. They told that no, that is not allowed. So these type of points we are not able to square it. And then we also wanted to put some renewable energy, solar panels in the factory. And then we also put like so much car parking area we use it. So, but later stage we dropped the idea of platinum, but building is completed in that. And so this all it should be interdisciplinary discussion, and it's a must actually, because I involved in the project successfully. Almost 4 years it took us. 2 years we took almost 50% of the project time we spent only on the design aspect, and then tender floating, then tender evaluation, and then execution and all the things in that. And so basically any type of possible, ideally involving those who will be responsible for the services in use. The members of the facilities and IT team, this discussion will help us with the flexibility requirements to accommodate the future change. Because integrated design, you should involve all the people, because you should always forecast when you design the building. And this many times it is not happening. And I know there could be some difficulties, the availability of space and all the thing. But if everything, if you have at the design, at the starting of the concept of the design, if you spend more time and give a realistic cost, but because to give the realistic cost, what we need a database for the costing. And many times the most of the consultant they don't update the database, because this costing is also related to the inflation. So that has to be updated. Many times we don't do that one. And then this creates so much issues when we do the tender analysis and when the tenders are opened actually in that. So this type of things definitely you can consider, which I also felt, because here we may not have that type of database we don't have much inflation maybe 10 years ago. More or less the prices are very, very fixed, because the tax structure is very, very low here. But for the last 10 years, in Middle East countries also, they have various types of indirect taxes, and inflation is also definitely is there. Even the fuel price is not fixed here. Not same like India. Every month the prices are changing now. And so that way, now the cost consultants also, they have to update their database. Otherwise, 10 years ago, when I designed my air conditioning system, whatever the database, I can use it. But now it is not the case. I have to also take the inflation rate factors in my costing in that. So you have to also understand the function, the clear function of the building. Many times at that stage, that's what the need statement. Need statement of that building should be very clearly to be understood by all the stakeholders. Many times even the owner does not know what for he wants, that he looks in a different angle. I have seen so much cold rooms in the northern part of India. I'm talking maybe 90s. Many cold rooms, and that is not properly designed, and they don't use even proper refrigeration equipment. Now the situation must have changed. I have done so much study. I traveled almost Muradabad, everywhere where they keep so much meat and the cold rooms for meat cold rooms where ammonia plants are there. And they always keep all these slow speed compressors, maybe which normally runs 300 RPM. And nobody is ready to use these high speed compressors, and which energy efficient compressors, energy efficient system. So I have also interacted with them those days. Why don't you people, owner, when I went them, the owner is not, because for him, his calculation is based on this much space area, and he does not bother about the energy. Because when it comes to refrigeration side, mostly the refrigeration decision is taken by the people who are operating that refrigeration air conditioning. And then most of the mechanics, they're very comfortable in the slow speed compressors. Because those days I'm talking about the reciprocating compressors, we may not have this type of advanced high technology scroll compressor or screw compressor, not even servicing. They are very familiar with that. And they are also not really updated. The high speed compressors, though it is reciprocating, in the design part, like we have if you go to slow speed compressors, they have the design is very simple. They can easily open it, the valve read and all the things. But when it comes to this high speed compressor, the design is so slightly complicated. So I told the particular owner, and we have presented so much technical issues in a very simple language. Even we translated to the local language. We conducted a workshop, a chain of workshops, brainstorming sessions. We brought them to all in one table, owner as well as all the service people. And then they understood. We have done some study also. How much, okay, maybe the capital cost will be slightly more, but the recurring cost, because we were based on the current consumption, because the slow speed compressors and these high speed compressors, the energy consumption is so much. But sometimes those days, we don't have this type of institutions to monitor the energy consumption also. So that was also one of the reasons those days. But now the things have definitely changed. So the function of the building and this application of the refrigeration equipment also. And then as a legal requirements, like if they come tomorrow, like Delhi and all the things, if they put any building now you want to design, this need to be have minimum of silver certification of the LEED or the green building of ASHRAE, whatever in India in that. If they make it as a mandatory requirement, then probably we can promote more green buildings. But I think in India, now because of the awareness, and maybe one of the reason awareness, another reason is also the energy tariffs are also definitely very, very high, different also. And that is what exactly Middle East also now is coming. Middle East now, earlier, the rates were very, very fixed, irrespective of the building, what type of building in that. I'm just telling an example. In Oman, produce 1 unit of electricity, 1 kilowatt hour, we spend almost 50 to 60 paise. And what I pay for the last maybe 15 or 20 years, 25 years, 24 years, the same amount, 10 paise. So almost 60 paise was highly subsidized. But from the last year onwards, or maybe 2020 or 2021, the tariffs have been completely revised. And that first they introduced in the industrial area, industrial buildings, and then slowly they move to the institutional buildings, all this market. And if you are consuming 1.5 million unit per annum, and if you cross that one, then you have a different tariff rates, which was used in earlier in all these countries, even developed countries, they have different energy tariffs. And in fact, in the US and all the things, this was used maybe many decades ago. And but in Middle East country, they started using now only, especially even the normal people, common people, now it has started using only this 2 months backward in Oman. For that also, there is a lot of resistance. The local people, even they're also now, they put, if you are an expatriate, you have to pay a different kind of tariff. And then if you're a local citizen, for them, there is a different kind of tariff. Then you may ask, sir, how do they know, understand all the things? So this is all there. They have a different identification. The database. They have a very digitalized system in that. The code, the moment you enter, the citizen also has a different correct, like what we are having, Aadhaar code, and similarly we have also called a citizen number actually. So if you put that one, all the things details will be available. That is digitalized. That is the advantage of that one. So it's a legal requirement. If any of the government, if they put in that way, India is really doing a wonderful job in that. And then minimum energy performance requirement national building code had to be updated every 5 years. Because the technology is also evolving. So what I have done, a national code 5 years, maybe 2015. Now in 2020, the technologies, definitely there are many technology advancements are there. And the ratings are also different. So that definitely to be updated. And that update definitely should be referred by us, people who are going to design in that. So the library had to be also updated in that. So these are various rating methods. LEED, of course, you know that. Similarly, we have ASHRAE, also have a different rating. And then we have and only for the energy, we have EPA, and then ASHRAE building is also another ASHRAE part of the one. Then particularly different state. America has got a different state. California is definitely doing so much work, does so much documentation. Again, California is a place where they don't have much water. They don't, and then outside the tropical climate, not like New Jersey or New York or Boston like that. And then we have a Chartered Institution of Building Service Engineers, SIPS, actually in that. And this all ASHRAE is ASHRAE as a quote, and we all different this thing that when we have in a two groups, environmental energy group, lead and ASHRAE, then energy only. This is what I told in the previous chapter also. Now come to the difference actually. Now ASHRAE building this standard percentage based on the ratio of the energy utility intensity of the building. And they always take the statistics is always very interesting. Yeah, instead of sometimes you take average, sometimes you take median, then you go for standard deviation, or even you go for regression analysis based on the data. So that EPA normally they go for the Energy Star rating in that. So on that basis, they also distinguish in that. So these all probably depending upon your local, when you are designing what type of code you are going to refer. It all I leave it entirely to the team in the design team in that. But general idea is when you design, one is from the product point of view, chiller side. So what type of chiller, what maximum we can do? It is available. We know that every manufacturer has got different kind of EER, but that also they put some conditions that EER subject to that condition. But when the operating conditions also vary continuously. So on that basis also, you have to also put in your design selection, because as I told you, when you take your inside temperature, outside temperature for the design calculation, how you take, like, are you taking CDC cooling degree days, or you take the extreme condition, and on this all, it comes so in the first class also I told you, it needs so much mathematical modeling and then so much analysis. So that really helps you when you do advanced software tools in that. And similarly, when it comes to the air distribution side, as much as possible, air pressure losses, and then use fan technology, because fans and blowers is another interesting topic in the air conditioning design. What kind of fan you have to go, and you can always compromise. Is it a centrifugal flow or axial flow fans, and how much CFM you want to handle it, and it all depends upon, again, application to application. If noise is not a main consideration, accordingly you can go. And then fan efficiency also, because fan technology is also improving. And then now VFD is also variable frequency drives. This is also maybe another 20 years back only. This technology is now evolving so much advanced. And then we have digitalized controls, demand control ventilation, some of the things we have discussed earlier also. Then we have also powerful heat exchangers now, air-to-air energy recovery. So this all where we can focus. As I told you, this heat exchanger design. Generally, we always use copper tubes, aluminum fins, or maybe copper tubes, or maybe copper fins, depending upon your design, depending upon applications. Like I was designing this seawater air conditioning. That presentation probably I have shared it with you about 3 years ago. So we were thinking, like in Muscat, just as a temperature almost 3-4 kilometers at the depth of almost 800 meters, the seawater is available at 4 degrees centigrade. So what I need is I have to just pump that water, and I have to exchange it through a platinum heat exchanger. The heat exchangers will be definitely very expensive. And then normal water, I put the heat transfer. So the water will become, chilled water will become maybe 7 degree or 8 degrees centigrade. So that water I can circulate for my district cooling system. This was the idea. Maybe I don't know how many of you have seen that my paper, my presentation, what I have sent earlier. I shared it also. So this type of ideas definitely will help us for the energy saving ideas, and even fan also. So energy, particularly I'm talking about the heat exchanger in that. heat exchanger manufacturing, heat exchanger design technology has evolved now so much. Even there is a so much R&D is now people are doing on that. Now, come to the air handling system in that. One is product side, chiller side, and then come to this, as such, if you come to the refrigeration cycle, major equipments are compressor, and then you have both chiller as well as your condenser, or heat exchanger, including the cooling tower, if it is a water-cooled system. Then you also have the pumps. Of course, it's a mechanical product. Mostly the pumps, what we use is centrifugal pumps in that. And then you come to the controls. Controls, basically, you don't much in that because it's not consuming much power. The major power consumption is your compressor. So the compressor technology is also evolving, and very nowadays everybody is going for this. Even if it is a top of unitary type of air conditioners, those was the days earlier they used most of the air conditioners were reciprocating compressor, particularly this 1.5 ton and ton like that. But now rarely they use reciprocating compressor. Everywhere they go for rotary compressors because of the sleek design, less noise, and all these things in that. So now come to the air handling system in that. So in the air handling system, designing from the indoor air quality point of view, also you have to design, but also you have to also have the energy saving point of view also. That is your the controls plays a very important role. Many times, as I told you, the controls, the inertia is so much. Even you should not compromise in going for a low quality controls. You should always go for better quality and very reputed make, and which really which have so much sensitivity, durability, and this. Otherwise, most of this electronic controls or sensors life cycle is only 2 to 3 years, and then it starts malfunctioning if it does not sense it properly, and if it does not give the analog signal correctly, and then if you have some issue with your updating your digital data controller, and then the whole whatever the system you are operating during the operating time, the energy what you are trying to save, everything will become useless in that. So these are the various thing what usually you can go for. Particularly in the air handling, maybe you can put zone wise, and then you also go for a variable air volume system. Maybe 30 years ago or 40 years ago, we don't have that. We always go for a constant air volume system. But now we also have a different variable air volume system, another advanced, so much studies have done. And but we have also disadvantages we have system, which I will be talking when I am talking about the air volume system, and particularly operating difficulties, especially in the terminal level actually. And when we go for a single zone VFS system, some advantages, and ASHRAE is very strongly recommend 90. Particularly the fan coils with the chilled water coils and supply fans with the motors greater than or equal to 5 horsepower shall have the supply fans controlled by the 2-speed motors or variable speed motor. This is what the ASHRAE recommends. So this may be one reason, and we can always take it in that. And any cooling demands less than or equal to 50%, the supply fan control shall be able to reduce the airflow to no greater than the larger of the following. One of the full green speed, the full fan speed, or the volume of the outdoor air required to meet the ventilation requirement of standards, because ventilation requirements are described in standard 62.1, which we discussed, we reviewed yesterday in that. So similarly, optimization benefit when you try to optimize the fan pressure, because yesterday even Dr. Riyad was slightly telling, when I was talking about you also asked some question. Sir, when I put so much filters, so what type of the pressure drop? For him, he's an expert on the filtration side. So he always talks only, he looks only from the filtration point of view. But you being an air conditioning engineer, your interest is again, when I put so much like free filter or dislocation, fine filters, even infra filters, ultra filters, everything, when you add it, definitely the pressure drop across the system will increase. So that all you have to find out. And then your fan performance curves, you have to study very carefully, because majority of the time, our AHUs normally work on the park load condition. So this we normally do at the simulation level in that. So fan pressure and ventilation optimization benefit in that. So for that also we have point on that, just highlighting that. So now coming to the high performance chill water system, variable system, which I will be talking now. Can we have 5 minutes break now? Hello?
Sure, sir.
Okay. Yeah, I just will go continue with after 5 minutes break. Please, you can call me when you are ready. I'll just take some water.
I have a request for the Pinnacle team.
Yes.
We have selected a very, very interesting topic today. So we wish to know the intent of selecting this topic. And since you have selected this topic, you may having some specific questions or doubts. Then only you have selected this topic, and we appreciate that. So I suggest you, if you have any doubt, please list down. And in between, as the session goes, you can ask Dr. Ramaswamy. So he can be clearing your specific doubts pertaining to this subject, which you may be applying to your day-to-day life or calculations or something like that. So he may reply in parallel to in tangent with that. Or if you feel that all our doubts are getting answered in this session, then it's we are more than happy. That's it.
Yeah, thank you, Mr. Neeraj. Thank you very much. Actually, the idea of their course, we call this advanced HVAC this design course, very meticulously we have structured actually. When the outline course was given, so every step by step we are going actually. We started from that to structure that one only. And now even next class probably we are going to talk about the clean room, and then we are talking about the variable air. Then we are also finally we are talking about the heat pump separately. And then finally, we'll come to the ventilation, mechanical ventilation with the ASHRAE standard, as well as car parking, specialized this thing. That will be other part of the services in that, forced mechanical ventilation. And so that will be, which normally we don't involve much, the pressurization, air pressurization system, smoke evaluation system. So that does not much involve the refrigeration part in that. Little bit, actually. I cannot say that it not involved. That is the reason I kept that one as the last of my topic in that. But all these things I structured in such a way that the interest also develop, and then you will also slowly and gradually you will also understand. And then, but it is not the end of our class. As I told you in the first class, our relationship will definitely continue. We can always keep in touch with Mr. Neeraj through me, through Mr. Neeraj, and we will keep in touch also in that. Okay?
Yes, sir.
So, yes, sir.
Yeah, let's take 5 minutes break and we can rejoin.
Please.
Hello, sir. Can we start? Hello. Hello. Yeah, I think we should start.
Yeah, we'll start now.
Yes, sir.
Okay. Yeah. So we just completed how we have to optimize in the particularly the fan pressures. I also talking about the various types of fans selection, the ventilation, because ventilation load is very important in the heat load calculation also, and that also which gives points in the this thing in there. So now come to the variable air volume system combined with the chilled water. Chilled water can be a air cooled or water cooled, and depending upon that, even the supply temperature. As majority of the time, we design this load for a peak load condition. So you have to also have a proper part load condition, operating condition design, and then you should also selection itself. You should go for a high efficiency chillers, and depending upon the place to place, which some of the research paper in that way in US. So much work reports are available in ASHRAE from the Los Angeles, California, actually, in that, because that area in Texas and Arizona, there normally they do a lot of cooling in that. Other places, if you have most of the paper related with the heating, actually heat pump. So if you really want to refer a lot of library research papers in the ASHRAE, you should look from the California and Arizona and Texas and then Mississippi, that area. So that will more related to our Indian design. Now, Middle East, most of the time we have a cooling. I told you this is what that when I was telling about the building code, Estedama. That means in Arabic it is called sustainability. It is initiative which normally take the whole UAE for the sustainable urbanization, considering the environmental factor, economic factor, cultural factor, social factor. See, if you see their architectural of the building, our architecture of the different, we have different kind of architecture. If you go to US, they have different kind of architecture of the building. Normally, if you come here, and they don't provide much the shades in the windows, and they also have this dome structure of construction. So these are many things you have to consider. That is what this all you have to take into consideration. These people have considered, and they developed a very good documentation. So that the whole Middle East, you can take it as a reference point in that. I think I am trying to search that document. If I don't have, I will download it and I will send it also. This may be useful for you when you are trying to some project here in the Middle East countries in that. And then, as I yesterday, we have clearly discussed about the various kinds of calculations, ventilation rate procedure, indoor air quality modeling, and particularly when we are talking about the mechanical ventilation. And then some places you may have a possibility of allowing the natural ventilation. So these all SIPS has done a very good research on that, because those countries, if you go to UK and all the thing, the outside air not that much polluted actually. Now maybe the situation will be different. Interior, that means they call us not in the cities, not like London or major developed industrial area cities, but other places normally they try to get more on natural ventilation also on that in their this thing in there. So yesterday we talked about the ASHRAE standard for the ventilation purpose. Ventilation means and ASHRAE general ventilation for indoor air quality. But when it comes to hospital design, we have to talk about the ASHRAE 170, the ASHRAE fundamental in that. And this also yesterday I discussed more about the indoor air quality procedure, ventilation procedure. So in that also you have a lot of opportunities for the energy saving code. We have also talked about the zonal calculation, how we have to write. Now the question will come. Sir, should I follow ASHRAE code or the local building code? This is the doubt everybody will have. Because ASHRAE 62.1 or ASHRAE is 90.1, or you are talking about ASHRAE 170. So now we have a local building code. Which one I should follow for the ventilation purpose or for everything? So generally, you always go with the ASHRAE. Ignore the local code. No, that is not recommended. Similarly, comply with the code, ignore the standard. That is also not recommended. So what is the ideal way? What is the correct way, optimum way? You comply with the code, request variance for that appropriate, because these standards are prepared. All these professional bodies, they develop the standard for the given purpose. The local code, they know they have also legal commitment. Judicial, they know, understand. So that probably you have to go with the comply with the building code, energy efficiency building code. Like for example, if you are in India, we have Energy Bureau Efficiency. So that code, they have so much documents, so much, even they give the certification also. They have exams also they conduct for the energy auditors. If you are a qualified energy auditor, you can always do the energy auditing of the building, and you can do the STAR rating and all the things there. And they conduct, I think, I remember about a few years ago. So this is the ideal condition. You should always comply with the local code, or if you are designing for a Middle East country, this is what I asked you. When you are designing a building in Oman, you always should go for what the local building code says. And we, unfortunately, some countries, they don't know local building code. Then we go for the standard. If there is a local code, then find out. More or less, these codes are also developed based on the professional bodies database only in that. So that is the thing in that. Now, this is what I was telling, the product design, in the particularly the heat exchanger, because if you see the refrigeration circuit, this micro channel heat exchangers, it is also another upcoming technology, which normally I have attended 3 years ago or 4 years ago on the online course on this. What are the benefits of this micro channel heat exchangers, particularly the air cooled system, air cooled condensers, and all these unitary type of package units and all the things. So they are climbing, and the refrigerant charge also almost 30%, because mass flow of the refrigerant is also very, very important. Now, if you say about 200 tons or 300 tons, huge amount of refrigerant you are going to charge, and refrigerant is also very expensive. And then each refrigerant has a different kind of properties, different kind of boiling point, different kind of viscosity, different kind of density, whatever kinematic viscosity, all this, that is the refrigerant properties. So that is all that, of course, normally the manufacturers, they decide it. But the heat exchanger part, maybe you may tell, sir, which we are not going to select this type of thing. Maybe when you are going to design your cooling coils, your AHUs, maybe you can always insist for this type of micro channel heat exchangers. You can put in your specification. So that will definitely help you in that. So similarly, when you take the outdoor condition, like you have to always consider latitude, daily range. This is also very many times people they consider in that. Maybe in your software it may be there. Similarly, when you go for the indoor condition, the end user, what he wants, you can always try to have a flexibility on that. Normally, the architect may not, as I told you, in every air conditioning, the initial design is always a raw data. They don't give you don't give you 10% of the data what you want. Many times you have to have the assumption. So that's what the data collection is also an art rather than a science. You have to go with and you have to meet with everybody, get the data, and then wherever you have the weak links, wherever gaps are there, as much as possible you get, and then you go and educate them and get the data, because these people may not be knowing all these things. They don't understand these factors which is going to impact on the design of an air conditioning system. In that, though these people have given recommended indoor conditions and all the things, and more than that, probably the end user, if there is a flexibility. I have also told my case study when we are doing this clean room in the Hindustan Cables Limited many years ago, and the consultant or the people, they wanted to have 80 degrees centigrade inside, which I felt is a waste of energy. So later stage, when I discussed with the process consultant, they agreed, no, they need only about even 26, 27, 28 is also okay. Just imagine from 18 to 26, the 18 degrees required some amount, 10% or 20% of the total area. The area may be 50,000 square meter or something in that. So this type of thing, basically, you can always interact with the similarly. Similarly, when you do the heat load calculation, generally what you do, if people normally you depend all the time your software. So software is basically whatever the data you have given, it will give you the value. But I strongly recommend, if you really want to do it, identify the building materials. That also the initial will be very difficult. But follow with the architect, building material and what type of local materials available, and all the values you may not have available in the data. So you have to use always your guess and then find out accordingly. You have to find out. Then also the safety factor. I don't know when you are doing the heat load calculation for the sensible heat and latent heat, how much safety factor you are taking now?
In manual calculation, we go with like 10 to 15%.
Yes. Or yeah, okay, that's right. So sometimes I know, I still remember when I was doing, I normally take not more than 7.5%.
Okay. Is it for software?
Now, just now for sensibility, they normally take latent heat, they are taking 5% only. No, those days I normally do manually only. Even here now, basically when we use, we normally take the same. For the sensible heat, normally we take 10%. For latent heat load, we take 5% only. And then duct loss and all the things, average we take 7.5% in that. So then whatever the software we are using, that should be also approved by the government regulation. This is also very, very important, because sometimes I don't know, the data are not updated. So that is very, very important. The local code also, what they say is that. So these all the where you can always have the, as a design engineer, you can do that.
Doctor, I have one doubt.
Yes.
Sensible heat and latent heat safety factors 10 and 5%, are they specified in the standard, or it's a general industrial practice to take
This is a general industrial practice. Actually, some people go for even 7.5% in that. Because this.
Why do we have that difference, sir? Sorry for
loads all. See, when you have a process factory, yeah, because latent load contributes too much of load on your chiller. Your moisture removal, if you see in the psychometric chart, your load, monsoon load will be always very high, isn't it? Your latent heat load is always very, moisture is always source of heavy load in the air conditioning heat load calculation. If you take the table, the latent heat will be always very, very high. If, because all, like even equipment load, if you consider, if you fan and all the things, most of the things are sensible heat. But when you come to the latent heat, any product you bring, like any product, or even occupancy, if you are a person, his latent heat load, your body odor and all the things, so that has to be treated properly. So the latent heat load always gives more load on the system in that. And then similarly, the cooling tower, particularly the water cooled system, it has got a lot of advantages, but cooling tower design is also very, very important. You know, if you don't design it properly, cooling tower, if you don't operating parameters, and especially if somebody goes the cooling tower, if you don't have a proper data, the approach, like places like Chennai or even Mumbai, and definitely the efficiency of the cooling tower will be always very less, because the outside most of the time it's a high humid air in that. So that also fluctuates. The evening time, most of the time the humidity goes very high during the late nights, evening time, or even the early morning hours, night time. As the daytime goes, when the dry bulb temperature increases, the humidity also decreases. This is basically from the psychometric chart in that. So similarly, you also should select the energy efficiency ratio from the catalog in that. So finally, we always go for the VFD now, variable frequency, because most of the time we always use this type of fans and all the things on the partial load condition. VFDs are definitely another latest advanced technology which really helps us to go for energy saving in that. So you should always ensure that these VFDs motors are involved in your design in that. That is a must actually in that. And that is particularly wherever the mechanical ventilations are there. Now, most of the manufacturers, they have a VFD, and even not only in fan and even pumps also. All you can see VFD pumps, your motors, even air conditioners now. They call as inverter air conditioners, isn't it? In the market, everybody the marketing like that. It's inverter air conditioners. So basically, they know that. But generally, in the room air conditioners, I don't anticipate much scope on that, because more or less we don't do any design on that. We normally this much area, thumb rule. A bedroom is cost about 20 square meter or 18 square meter. So I will go for 1 ton or 1.5 ton like that. So though they are calling us an inverter, I feel that it is more or less like a marketing thing rather than. But VFD definitely plays a very important role in the central air conditioning system in there. This is what I'm telling, the moisture load. Moisture load in the building design is a very, very important. Anywhere it can be maybe pressure difference because of the difference between the mechanical ventilation, stack effect, and maybe the wind. And the moisture load, the latent heat load is always carries so much energy. Removal of the moisture, if you can probably, if you do the psychometric analysis, you can see that actually in that. Similarly, you have to also put the proper eliminators in the coil with the supplier in the AHU design. Otherwise, you have so much condensation will happen in the ducting side, and the ducts also properly to be insulated. And many operating time I've seen, if they are not properly insulated, and that is also a huge amount of energy loss. You cool the air to 12 degrees centigrade, and you take the duct maybe 200 meters, 300 meters without proper insulation. So by the time when it reaches the outlet, the supplier outlet, it will become the heat transfer. Heat is immediately. The more the temperature difference, the more the heat will flow. This is a simple thermodynamics law. So similarly, dew point temperature, you have to be very, very careful about that. That also I mentioned on that day. If your ADP, if you are maintaining your surface temperature below the ADP of that your design, definitely condensation will come. So the condensation occurs means it's another issue of the moisture growth. The moisture will definitely allow for the fungus and mold to grow. So this type of thing is that you have to definitely look into that. So I am just trying to go to the another one now. Next slide. And just please wait now. I will just open it now. You are able to see now?
Not now, sir. Now we can.
Yes. Yeah, this is again a continuation of that one. And this, I'm trying to focus more on the Indian sector, part two. So far, we have talked in general. There are a lot of opportunities in the first part. We covered basically product as well as air handling and duct design, and then BFDs, and then whether we should go for ASHRAE standard or local building code. So I thought that probably I have done some study about this Indian energy pure efficiency, and I also browsed it actually on the Indian side, cooling side. And Indian government is definitely doing so much work on that. And they are also anticipating the cooling demand will go almost double in 2020 in another 6 years. And because of, as I told you, air conditioning is not a luxurious now, no more. It is a part and parcel of the life. And then the quality of the life of everybody, and then even look with the increasing outdoor air temperature and extreme heat condition. And then you have urbanization also. So the city is now expanding exponentially. And then so much pollution and everything. So everybody wants, all the air conditioning is basically a part and parcel of the life now. So we also need so much energy actually. And most of the energy what we are producing for cooling from the buildings only. This is what the statistics says. 57% of the Indian energy demand for cooling comes from only from the buildings. So just imagine about the other industries, processes, different. So building, as a building service engineer, you have a great responsibility on that. And then if we really use the proper practices in the design as well as the servicing of our cooling equipment, definitely there is so much opportunities for the significant change of the energy. So the government has really taken the cooling, that's what called as, maybe you must have heard about this one, Indian Cooling Action Plan. This I read probably a few years ago as a driving mechanism for the sustainable cooling solution. So that their emphasis basically, they want to have a benchmark. They want to reduce the cooling energy demand by 25 to 40%, and refrigerant demand by 25 to 30% by with this range by 2037. That means another 16 years. And with the from the base value of, they have taken the base value of 2017 to 2018. This is what the mission of this Indian Cooling Action Plan. This is what this ICAP was maybe 3-4 years ago. They planned actually, because though this it's again offshoot of the COP. We have already one of the signatories of Conference of Parties signatories in Paris with that. So they have also given so much technical recommendation. I hope if you have a time, you can go through that one. Otherwise, if you want, I can share it in my reference material. Very interesting. I read in that. Only I have taken the synopsis from that. They've given so much recommendation. Now, one is the low carbon cooling segment as a focus area for the state and private incubation centers for the encouraging innovative technologies, business ideas. So this is also one of the things which in first class I told you. I have one student, a very intelligent student, and he 2-3 weeks ago he called me. Though it is a small, but many smalls only make a big actually. So he was trying to have a idea to how to convert this thermoelectric Peltier effect as for the air conditioning purpose. So the design, everything he is now doing, and he is making a prototype. Even the government, we strongly recommend the university. We have also selected him as an innovative project, and now the prototype he is making in that. It is same like, in the automobile sector, when the electrical vehicles started coming now, and refurbishment of the old vehicle. This is also very interesting, isn't it? This is what again I'm telling. When it comes to our automobile sectors, we have done so much advancement. So much embedded system is played into the safety point of view, the engine performance, even the sound and everything. Same probably you may ask. We must have definitely advanced in the refrigeration side. But if I say comparatively, we are not that much up to the mark of what automobile sector has achieved. This is one of my my personal concern. I addressed many platforms actually in that. There are many ideas. Many ideas are there. Alternative technologies are many there. Why can't we explore it? Even in the, like for example, when I was doing my engineering maybe 42 years ago, I have done car air conditioning. Maybe you must, I don't know whether you people, normally in the car, what we do, the compressed, we have an engine power, we take almost 15 to 20% of the power by the compressor in that. It is connected with the clutch plate and this one. So we thought that, okay, we will try to use your exhaust gas is almost 300 degrees centigrade. So why can't we use this exhaust gas for using the air conditioning system? So we thought that we can use this vapor absorption system on that. On that basis, as a student project, academic project, we did. Even those days, we don't have this type of sophisticated cars. It was only the maximum car was Ambassador or maybe Fiat. These are the two cars were available. Even to get the data, because I have to keep my heat exchangers where I can keep. Engine space is already limited, so I have to keep only in the dicky. So I have to have a sacrifice. So dicky space is basically designed. The need statement of a dicky for a car was to keep the luggages. So if I am going to occupy the dicky for keeping my equipment, so or I have to opt for my engine space where I have to keep this fitted there. So, but this was a student project, academic project. We had so much limitation, but the idea was definitely interesting in that. So that's the same way we have the government is also encouraging in that. So this is how now we are also integrated design. We talked about that. A poorly designed or commissioned HVAC system can significantly increase annual energy consumption. Your recurring cost definitely will increase. But definitely, if you are designing efficient system, it not only efficient system, it's not only selecting the best ER efficiency or something like that, but you have to also integrate it properly. So that's what I'm telling you. It has to be integrated. It has to be designed. It has to be properly commissioned, installed, tested, and then maintenance subsequently. So many things are involved in that. So generally, we know the various kinds of building codes, how the building codes are classified. Some of the buildings I must have missed it. We have a hotel industries, we have healthcare industries, business buildings, all offices. Even the different offices have different some factories, workshops, shopping facilities, process industries is another one. Oil industries or chemical industries or textile industries, cold rooms industries or agricultural industries. So much. So the commercial building itself, it grows almost 9 to 10% on average. So, so that's what we have Energy Conservation Act. This is what one of the legal requirements. So that's what this act says, that it's legal framework and institutional setup for the energy efficiency policy, including energy conservation building code. This is what I'm talking from the Indian point of view. On that basis, only all this code and everything, they fix the target in that. So what is basically the energy ECBC does? It always encourages generally optimal sizing capacity. They fix the baseline also, and they also send that the equipment should meet the minimum efficiency standard in terms of COP or energy efficiency ratios, whatever they must have prescribed depending upon the type of building in that. Then they also recommend various parts like cooling towers, condenser fans, chilled water pumps. Then they also recommend you should use all these variable frequency drives, use the economizer. Then they also specify insulation requirement depending upon your temperature requirement for the pipes as well as duct, depending upon the distance, and all this available in the building code in that. So you have to refer. I don't know how many people are referring that one, but this type of information may not be available when you are designing for the Middle East, particularly Oman. But if you go to the Estedama, that Estedama also available things will be very, very less because they don't have a data. The database may not be that much updated, particularly insulation material. They may have a very limited insulation material because they normally take it only from the suppliers because they don't everything they import it. So they may have only one or two. That is what I was telling. Every 5 years, this type of building codes have to be reviewed and be updated. Now, similarly, if you are going for a natural ventilation, they should also comply with the guidelines. Now, I'm just telling now some of the building here, one of the hospital here, it was designed by a UK consultant maybe 40 years ago. A room inside, they put a split air conditioner, floor mounted. Those days, even they were not put the ceiling mounted, but there is no fan. No fan. So you know the advantage of the forced air convection actually. Many times you need not run to the run the air conditioners because maybe in the month of November or December, if there is a fan for the air circulation, even just you open the small windows, and that will give some ventilation. You don't need to run air conditioners. But unfortunately, here it is not like that. You have to run all the time. Otherwise, you will have suffocation in that. So this is what similarly you have most of this ECBs was developed by Urban Department. The Energy Conservation Act, the state government, because though they also empower the state government. We have a federal government, so every state government got their own code also, and then they should also notify to amendment. They review it and they should review it to this ECBC to suit the regional and local conditions in the state gazette. So much legal requirement is going on in India. Similarly, they must be doing in various states in USA also. But that is not the case here. So this all we know that when we start implementing this type of ECBC 2017 in India, and this what they're telling actually, if you start implementing, you definitely are able to save 50% energy saving by 2030 if you are designing the building based on this. And then you are going to reduce almost 15 gigawatt peak demand reduction because the load will also then you are also be able to save almost 250 metric megaton of CO2 savings in that. So that ECBC benefits states and all this, they should always have everything. Every state has got their own requirement in that. Then I said, told you this is basically you have to go for a cohesive decision. What is you have fixed the building fabric, energy efficiency. That is the central focus. Then you have testing side and then design side, and then finally the commissioning and all the things. So that is the only figure graphical representation. So some of the critical design check, how you do it that is the building is correctly oriented with regard to the prevailing wind and sun direction in this design stage itself. Because as an HVAC engineer, you always to have a data, or whether it is meeting as per our local building code, because architects also they follow, but you can always check it up with that. So your or the areas are arranged to minimize energy requirements. Some places the flow, the architect look in a different angle. But when you go and say the areas, you may always have a suggestion. And the flow of the areas, the meeting of the area, because this is what, again, at the integrated design, at this first this slide I mentioned, in that every communication, every stage, you have to interact with each end user. You like services in between, if you put in the middle of the building, or you want to put the building at the extreme end, how much loss will be there, pressure losses will be there. So these type of things probably, just one example I'm telling you that. Similarly, have you done all the calculations? These are some of the checklists. Have you done all these calculations for the insulation material, selecting the heat transfer coefficient? So what type of air conditioned area, shading factors, walls, the floors, even doors, and what type of window mechanism they have, and because you have so much infiltrated road. So this all in the checklist probably you must develop. You must develop based on your local code in that. So this will as ASHRAE 91 point, they have put certain process in that. And it's a collective views of the manufacturing, because in this, it's a compilation of all the views for the manufacturers and the construction and communities. And then they also set minimum requirement for the energy efficient design and construction. So it is a very interesting document. It's a very big document. I think it is there in your reference notebook. Various chapters are there. And in that, they also apply all the standard would apply, whether the heating or cooling, the standard should be applied in that. And they also given, this is, we see various chapters, is a chapter wise, what is the scope and all the things. So basically, the chapter 6 is mainly applicable to us, heating, ventilation, and air conditioning. Other things probably, I strongly recommend you should review it. If you have any doubt, you can always refer. If your architect is talking something about that, but this is again related with ASHRAE. Now you may tell, sir, this ASHRAE is telling like this. Now what my local building code is telling something that. So which one I should refer? But to my knowledge, most of these local building codes, when they develop, they always take this type of codes also as a reference material. So whenever there is a difference of opinion, you prefer to the local code, because ultimately you need to have a legally, you are answerable to the local regulation in that. So similarly, chapter 10, electric motors, regulates HVAC system construction like that. So these all compliance path, how you have to comply various paths and in the energy rated. Then they also talking about the efficiency rating matrices. Now, everybody has got a different kind of matrices, like we called, somebody was called up a COP, and somebody called as energy efficiency ratio, nothing but kilowatt per ton. And then they called this seasonal energy efficiency ratio, particularly for the central air conditioning plant. And then they also called annualized metrics such as integrated part load value, IPLV, for the chillers, and integrated energy efficiency ratio, IER, for commercial rooftops and variable refrigerant for VRF actually. This is another one, VRF system is also latest one, which is now variable refrigerant flow in that. And then we also talk about the seasonal energy efficiency ratio for the small package plant. So the annualized matrices are a much better representation of the true performance of the equipment, because most commercial equipment cell basically is runs at full load. That you and everybody knows, because we designed for the peak ambient condition, but that hardly occurs in a year, few days or few hours. So that industry is also, that's what this industry is gradually moving the emphasis of the efficiency matrices from the full load matrices to the annualized matrices. So don't go for these full load matrices and go with the annualized matrices. So for that, you have to refer this type of data. Your local codes will definitely be a very good guiding factor for you to design a better energy efficient system in that. So you have to also compare the relative performance of the different type of systems. And you have to put in the system. If I go for a vapor compression system, or even if I go for a reciprocating compressor, or if I go with the scroll compressor, I know there are certain standards depending upon the load, but you can always go with various design aspects in the refrigeration side, and then when it comes to air conditioning side also. This type of analysis you can do through the energy modeling in that. Now, you see that the EER, I'm just telling an example, how much research and development we have developed now. In 1982, in the residential sector, they keep 7.14. Now, in 2002, it has become 9.754. So that much improvement in the product they have done, product development they have done. So this is what the research organization like Oak Research National Laboratory, ORNL, when I was using their heat pump model, which was developed 30 years ago, it was so structured, the program was, so much correlation, so much compressor, local compressor-based models, and only one area, probably the capital design, they were using this heat and trial method. Otherwise, the heat exchanger design, the compressor design, it was very excellent. So this type of modeling, and then that is how they normally improve the product design in that. When it comes to central air conditioning, we focus more on seasonal energy efficiency ratio. You see that now 2006, it has come to even 13, isn't it? So this is much advancement development. Now, similarly, when I, as a thumb rule, yeah, maybe 1970s, if I take, just taking for the peak load, for this it was 0.9 kilowatt per ton, but now it has become almost 50%, or maybe 0.75 or 0.73. Even when we selected our this train chiller here in this thing, we have taken 0.72 or 73 in there. That's what they have quoted us in that. So these all for the various type of water cooled chillers, air cooled chillers, how the development started with ASHRAE as well as with the Energy Conservation Building Code, Government of India, both. So this is some of the standards with the COP as well as with the integrated part load value also. So this figures how the development started taking place in there for the water cooled chillers as well as water cooled air cooled chillers. The earlier one was ASHRAE. This is with the local Indian part in that. So we know about the inverter actually, about the VDF. So I don't want to go more detail onto that. We know that definitely it is proven fact that the VRF technology has really benefited us, particularly on central air conditioning system. I don't know, maybe you may ask, you may also evaluate yourself whether it's useful in a unitary type, particularly the local 1 ton or 1.5 ton. And as long as if the costs, they don't charge more, then it's okay. So there's no disadvantage on that. So we should also have there is certification process. Many of the chillers, I don't know whether you are going to put this AHRA certification process, because AHRA is another important institute, research institute, American Heating and Refrigeration Institute. They do so much certification, so much courses. They have recently, they opened office in Dubai, this AHRA in that, because they know that the most potential area is Middle East, where these cooling equipments are used in that. So I have also seen some of their president in the various conferences or the meeting in that. And they normally do so much documentation, so much process. They also give the certification. So you should, when you are writing your specification, you should specifically mention they want that it should be AHRA certified. It's like quality accreditation. Like last time when I was talking about the hospital accreditation, somebody was asking what are the things. Yes. So in that, if you go for the checklist, one of the checklists, are you following this type of standards? So for that, there will be weightages will be there. So the verification of the equipment efficiency is very important. And then more than that, they may be the certificate. But even I strongly recommend what I told in the first class. Suppose you are trying to take higher capacity, very special, very critical equipment, you should always go to the manufacturing plant and you should do the performance test at the site itself. Sorry, at the manufacturing place. And then you verify, issue the test certificate. And then after coming back, when you are installing, that time also we can verify that one in that. So when it comes to ventilation system controls, yesterday we discussed ASHRAE section, all this for the fresh air. But here, when it comes to the ASHRAE 90, the section 6 heating and cooling section 6, in that section 6 4.34, they talk about the ventilation system, all particularly about the controls, how we can control the chamber leakages, ventilation fan in that. So this is also maybe when you are doing design. So this type of design definitely you can recommend actually the manufacturers also in that. So pressure drop. Normally, we always talk about high velocity, medium velocity, low velocity design. So how much the pressure drop will come? Why you should go for a high velocity? Why we should not go for a low velocity? Because if you see the capital cost, generally we see that if I design a high velocity, the capital cost will be less because you know less material. But fact is not that. The research what they have done, if you see the system velocity for a capital cost, for low velocity, you have the capital cost is low. You see the figure in that. In the figure, if you compare it, and because you have to compare when you have the high velocity, the pressure drop is very high when you go for the higher velocity. But when you go for the low velocity, your pressure drop is less. So the electricity cost is less. And so accordingly, the capital cost will be also less in that. So this is just for comparison I have given in that. Similarly, we should go for a direct digital controller DDC requirement, which I was talking about the BMS and the sensors and all the thing in that. So economizer basically always most of the time so much air we are taking out, particularly in the outdoor environment when you are taking, you need to have a proper heat exchanger, air to air heat recovery, and that air to air heat recovery exchangers also you should properly design it in the design stage itself. Then this is some of the sections we talk about that what type of dehumidification you have to do, what type of humidification. Generally, the dehumidification if you do it in the cooling coil, because cooling and dehumidification depending upon the number of ADP when you are taking the design. And but the use for the humidification, it's always we use steam humidifiers because you always put some preheat jacket that heats up the steam injection nozzles to avoid the steam condensing in the duct system. Because majority of the time when you include the humidifier humidification system, particularly in the clean room areas, when you design these AHUs for operation and operation theaters, and you need to be very, very careful. And AHU manufacturers also, all the stages you need to have a check mechanism. And otherwise, in one place, if you ignore it, and that definitely will have so much impact. And during the operation time also, and then whatever you are doing, it will not be this thing. And then this section, fan efficiency, beautifully they are talking that nowadays fan technology has so much advancement. There's fans and blowers is a very specialized subject. It is nothing but a mechanical engineering centrifugal pumps. But because fan is nothing but you are handling with the air, and a pump is handling the blower. So most of the time centrifugal blowers. It may be forward curved or backward curved or normal curve, but axial flow also has got its own advantages and disadvantages. So these are the fan efficiencies talking about this section. Since it was 90.1, these sections are given in that. Similarly, the submission completion requirement, ASHRAE 90.1 clearly says when you are talking submission for your building regulations and all the thing, you have to so what are the submission requirements should be there. So the drawings, manuals, system balancing section, system commissioning section, this is all the submission as per the ASHRAE 90.1. The minimum equipment efficiency tables also given in section 6.8. And they also compare it with all the things, minimum matrices for the equipment standard rating conditions defined by the ASHRAE. Even they also talk about the ISO. Then we also have a Association of Home Manufacturers, the DOE, Department of Energy, and we have a cooling tower institute. So all is covering in that section. In that. So this probably you have done a special class on the data center is emerging now, maybe for the last 20-25 years. This data center the organization system is a very specialized subject because you have so much sensible heat in that. So that already you are a specialized course on that. So we have also, as far as Indian Bureau of Energy Efficiency, and they have put some target actually. They are also doing wonderful job. What they are telling, the current penetration of the low carbon cooling technologies in India is noticeably very low. This is what their observation. And they're demonstrating that this segment faces challenges and requires immediate attention and collaborative action from all players within the ecosystem in order to promote growth. So this is the recommendation of this one. So this is a different technology. Mostly they used in Europe, particularly in UK. The radiant and structured cooling in that. So this is a simple one normally. I don't know how far it can be applicable in India as well as in Middle East countries. So far, I have not done one. But when I used to read a lot of SIPS articles, SIPS research papers, they do so much work. They embedded these pipes, cooling pipes, chill water pipe or hot pipes within the this is called as the structure of above the beam itself. So this is then it radiates to the natural convection. So thereby they avoid the forced convection in that. How it will be effective and all the thing, I don't know. I have not designed. So I've just for your information, I thought that this may be one of the. They are claiming that radiant cooling definitely it will improve the thermal efficiency because it will also help us to improve the insulation and air tightness.
Sir, is it like
So this is what they're telling. So how much? Yeah, yes.
like in this radiant cooling, do you think it is a better option at the time of heating instead of cooling?
Yeah, that is what still that's what I answered. I also told I have not done here in Middle East. Nobody knows that. But if you see in any all the research papers, journals, many paper it comes to me. I normally very politely send back them. I am not expert on that. But majority of the systems, because those European countries, they spend a lot of heating systems all embedded in that. In say along the wall, and their wall is also not like we are a brick wall and all the things. They normally go with the normal simple wall, knockout, very easy insulation one with insulated wall. So in between they embedded this type of pipes and then they circulate the hot water. So instead of hot water, they allow the cool water because there's been summer is hardly only 2 months, maybe May, June. After that, if you go to the whole Canada or even if you go to Europe or even US, if you come to this all New York and everything, only May, June, even May is also. I know even Germany and all that is even May, June, when I was talking to my brother, he was telling even that time also that outside temperature was 8 degrees centigrade. Just imagine that. So this is just one point which they are climbing. This is also one way probably we can save the energy efficiency. And but I don't have much idea because I have not done much work here in this part of the world. But probably you may people, since you are doing for your client in US, so that is the reason I have also included this one. And maybe in India also, I don't know how much it will be useful. India also, we don't know much because it also involves so much coordination with your civil contractor, the building design in that. So, and then again, I'm coming to the evaporative cooling system. Majority of the time, whenever you want to take, depending upon the projects, if you are taking so much outdoor air, why can't you take outdoor air, particularly when you have a dry climate? For example, if you are designing a air conditioning system in places like in Delhi, most of the time from the March onwards, March, April, May, June, these 4 months, the humidity, especially February, March, April, May, your dry bulb temperature goes almost 45 degrees centigrade. But your humidity is only 20% or 25-30%. So the if you plot in your psychometric chart, you don't need even air conditioning. So that if you are taking 100% fresh air, instead of taking 45 degrees centigrade, you use this air washer, cool that. I know you are going to dehumidify it. That is definitely a disadvantage. But now we have so much active dehumidification coil. There is a lot of improvement in the cooling coil design. Or worst case, we can use some of the another chemical dehumidifiers also we can use. So this is what innovative design. So the sky is the limit on that. That's what I'm telling. Like the same thing which I did here in this project. I was telling here when Oman Museum, we have this is a dry area. Many places we have to take 100% fresh air. So we have included this type of evaporative cooling system. And I know the water is very, very expensive here, but we have done analysis. And because of that, by cooling load, the capital cost has really reduced almost 20 to 30% in that. And the recurring cost also, it includes in that. So finally, what I'm going to conclude is, we know the building code, local building code is very, very important. It is to be addressed by the HVAC incident at all levels. Energy saved is energy generated. ASHRAE 90.1, all the time talk about the energy efficiency. We have a local grades and codes. SEER is basically for the Middle East. When the energy modeling is definitely very important, even the design stage. And then during the operation stage, we should go for the regular energy audit. Then we should always go for, in the design stage itself, we should go for the alternative technologies and then efficient controls in that. As I told you, energy conservation is a very important topic, a very interesting topic also. Starting from the beginning, you should go for the proper classification, what type of system you need. So from that time, in the pre-concept stage itself, you should focus more work and you should classify it properly. Then you also should the room volume, basically the ventilation range, where you have, because like I was telling, 100% fresh air, how much return you are going to take. So in that, you have a lot of opportunities to reduce the load in that. Similarly, air change, because the air change normally they recommend ranges 50 to 60 or 20 to 10 to 25. So both options, how much depending upon your outdoor, how you are going to take and how much amount of quantity of return air you are taking in that. Similarly, optimal equipment sizing, the factor of safety what you are going to take in your load calculations. Then when it comes to the distribution and the reduction pressure drop, also you have to select in such a way all this available equipment meets the local code requirement also. The right equipment location. This is again I'm telling you that. When you your master plan, when you are designing, that is also I told integrated design. From the concept, and again you put your services somewhere else, and then you take kilometers without much insulation, so much energy loss will be there. So that's a simple concept. Like in electricity, the power stations, the transmission loss, still we don't have a technology. You know, so much power what we are generating, we are losing into the transmission loss. Throughout the world, engineers are doing research how to minimize the transmission loss in the power transmission loss. So that is what nowadays everybody started going for the microgrid. And then you also have so much transformers, substations, and everything in that. So even now, when the renewable energy concepts are coming, we also are always talking about this universal grid concept now. So if when by using this nanotechnology, because I'm not going to that one. So right equipment location, then optimizing the outside air, selecting the high efficiency equipment based on the various local standard, whether it is COP or IPLB or energy efficiency ratio or seasonal energy efficiency ratio. Similarly, the right configuration of the equipment. So this will definitely help you to become a very good energy conservation engineer, and you can select the better energy efficient system in that. So thank you very much. And if you have any question, please ask me that. And if tomorrow also, if you are attending, probably I can talk tomorrow about the clean room actually, because this will be also another interesting related with this one in that. I'm leaving up to choice actually. The same time, if you want, I'm ready, but it's up to you.
No, Doctor.
I don't have any issue.
Yeah, management has spoken to me, and tomorrow there are no lectures.
Okay, they are busy, leave it, no problem. No, I'm just asking if they are telling tomorrow also working day. That's what I was thinking. Yes, because it's relevant. Immediately people have maybe as holidays they can use to revise it. That then when they come to next class, they can come with more questions in that. Lot of study materials also I have shared it. I will be sharing many more also. Whatever like energy study what I have done for a different kind of buildings. That paper I will search it today now, because I'm not that much organized. Some of the papers I normally don't put in the right place. So I have to search it and I have to send it. So that is a delay actually. Whenever I get this type of papers, I will definitely send it. I have almost published more than about 1900 research papers throughout my industrial career. I'm not an academician, even though I work in industry, but still interact, and then I convert this type of case studies, and then I send to most of these conferences. And then I also make any interesting paper which comes for my review also for the journal papers in that. If that type of some papers, interesting papers are there, I will definitely share it with you that. So thank you very much, and I leave it to you now. That.
Sir, this side Shubham.
Yes, sir.
When we were talking about that supplying cold air into the conditioned zones, instead of supplying it neutral, like if I'm supplying it air at say 48 or 47 degree Fahrenheit to a room, do we like generally?
That is variable air volume system. When you are combining chilled water system, VA with the VA. Yes. Yeah, that is for the VAV system. Because that's what VAV system, the advantage is, the supply temperature, they set point normally to 45 degree Fahrenheit. Normally now what will be your chilled water supply temperature? Generally we set 5 degrees centigrade or 4 degrees centigrade. And the return normally the delta T in any chiller, the delta T is normally 4 degrees centigrade. Just 1 minute, sir. So, yeah, with that that VAB system, variable air volume system, is basically 25 years back only. Otherwise, earlier days we always talk about the constant volume supplier system in that. So VAB system particularly is very efficient for the part load condition in that. So now when you are talking, I don't know how you are specifying your water cooled chillers or air cooled chillers. How much delta T normally you in your specification in the bill of quantities you put in the delta T? How much you are putting? 4 degrees centigrade or 5 degrees centigrade or 6 degrees centigrade when you are writing your technical specification?
Say for like my question was something different, but if you're asking, like as I know that 90.1 ASHRAE section, I guess 6.5.4.7 something, that says with that we should select a cooling coil for a minimum 15 degree Fahrenheit delta T. So we usually go with that. But there are times when I've seen some of the designers selecting it below that 15 degree Fahrenheit delta T. Sometimes they go with 12 degrees, sometimes 13 or 14 degree. So like are there any exceptions to this requirement that we need to select it more like for 15 degree Fahrenheit, or it is like a compulsion and must be followed in every design wherever we are using chill water cooling coils?
Yeah, no. That standard is giving one, but it all depends upon the our application also. Maybe if they are designing the designers like 12 degrees centigrade, probably I don't know what type of application actually the delta T in that, and what type of location. Many factors involved in that. But at the same time, you cannot now design with delta T 26 degree or 30 degree. The range is now, it may be plus or minus here 1% or 2%. It's allowed. But they cannot go more than that, because in that case, you may not have the efficiency, will not perform also, isn't it? Now, instead of 15 degree Fahrenheit, he has gone for 12 degrees centigrade, 12 degree. So there could be some factors in that, but there's no hard and fast rule in that. There's a lot of flexibility in that. Standard specifies certain values, and then there are recommended values. Now, if you are going here down and you are going even slightly up also, if you are going to get benefit for during your modeling time, during your analysis time, and that you can definitely take it in that. Standard, all the standards are only for guidance purpose, and it is not necessary unless otherwise if you have a legal requirement in the local building code. So if a local requirement code said no, you have to make, for example, inside condition. Local gate says that for a mall, you should not put your indoor condition 19 degrees centigrade or 20 degrees centigrade. So if you consider 19 degrees, they must have given it should be minimum 26 plus or minus 3. They put 25 plus or minus local. For example, Delhi mall. The mall and the local code says 26 plus or minus 2. But the ASHRAE standard says 24 plus or minus 2. So which one you will prefer? You have to prefer the local code, isn't it? So that's what the local code basically definitely has to be given more importance in that. And if you design, if you are trying to take now indoor condition, say 20 degree, then you are basically wasting the energy. You are also wasting a lot of capital cost, then recurring cost also. So this is how we have to use your judicially the code and standard with your experience and application to application in that.
I think Shubham, your question was something else. You said.
My question was, suppose I'm having a dedicated outdoor air unit.
Okay.
And with that, I'm supplying air that is just the outdoor air to certain zones. And instead of supplying the air neutral at 75 Fahrenheit, I have planned to supply it, say, at 47 Fahrenheit or something, 47 or 48. I was actually planning this one on a project I did earlier, and the architect told me some problems with condensation on walls because of that much low
Exactly. Yes. Because the difference in pressure will be very, very low, and you will be losing a lot of energy. Now you are cooling at your cooling coil. The design says you can do it for 75 degree Fahrenheit. Now
Like
you are
actually,
cooling it.
but sir,
Yeah,
like in that, the idea behind that was because, cooling, the outside air that was humid. So I
yes,
had to you dehumidify that. But
correct.
since I have dehumidified it at 55 Fahrenheit, suppose 50
Okay.
Fahrenheit, 55,
Yes,
then
yes.
to make it neutral, I had to reheat again. I was trying to, protect that reheating and supply
Mhm.
that outdoor air at 55, say 47 Fahrenheit, that much cold.
Mhm.
And I was thinking that, that much cold air will offset some part of the sensible load in the zone as well. So the terminal cooling
Yes,
unit, I
yes.
was thinking that could be sized a little, with a lesser capacity. So that was the idea behind that. Earlier, I was planning to put some, linear slot diffusers so that
Mhm.
there that much, that cold air could be distributed very well. But
Mhm.
that problem of condensation on walls, that became a major issue, and then and later on I had to supply air at neutral instead of
Mhm.
cold.
Yeah,
So
yeah. That is yes.
so in
Correct.
what
I think
climatic
yes.
conditions should we go with these kind of options? Because if architect would have allowed and the climate would have permitted, that
Yes.
could have been a better option. Correct me if I'm
Exactly.
wrong.
Yeah. Exactly. Or probably again, now. I don't know how much the distance actually. You are outdoor unit. You are taking this ducting and how you are taking your outdoor through conditioned air at a 55 degrees centigrade. Okay, you are dehumidified. Let us assuming that you don't use the reheat now. You are taking this 55 degree supply air, the air conditioned air. You are taking through the ducting. Then your terminal side. How this ducting has to go through on various level. How you have to through the shaft, or is it passing through the
There was just a
air conditioning area?
one-story school building, so there was
Uh-huh.
no shaft. I was just from the dedicated outdoor air unit. I was taking it to
Uh-huh.
the ceiling,
Okay, okay,
and then was
okay.
distributed. And
Okay, that is
just
the
adding
reason.
one
Yeah,
more point, sir.
yeah,
Uh,
please.
Actually, I have learned that 90.1, the ASHRAE
Yes,
90.1, that
yes.
also allows us, or in some areas, that restricts the reheating, and then gives some exceptions where we can do the reheating. But 90.1 generally says that we should prevent reheating. Correct me if I'm wrong.
Yeah, yeah, correct, exactly. Because you are basically you are cooling and then again you are reheating. It is an air based, and then moreover
Exactly,
the
sir.
reheating when you put the heaters, in particularly when you come to the VAV system, most of the time this reheaters all at the terminal point it creates a problem. In the operation point of view also, yes. In the VAV system, I mentioned it is correct. You are absolutely correct in that. Yes.
So, like, in what kind of situation, like, is it like a something which we cannot do in school building or should not do in school building, or some commercial application would be better for this kind of approach? Or maybe how about like optimization, the outdoor air optimization? Suppose I'm planning, and then I'll
Yes.
say that with that outside air, I will
Mm-hmm.
supply it at say 50 Fahrenheit. I'll supply it cold. With that, I'm planning, suppose, to offset some of the latent load and the sensible load in the zone.
Mm-hmm.
But suppose the occupancy drops down. A school
Mm-hmm.
which was earlier planned for 50 students in a class today
Yes.
is having just say 15 students,
Yes.
and we are having occupancy sensors. So
Mm-hmm.
with that, the BMS system reads, okay, now I need to provide just the fresh air for those 15 students,
Yes.
and that outdoor air reduces. So
Yes.
in that case, like, should I, size my equipment for those cases as well, the terminal, the terminal unit, because in
You know
those
that.
cases they
But
yes.
you must have also gone for VAV system, isn't it? The terminal unit, there will be a dampers will be there, which
Mm-hmm.
will accordingly when
Uh-huh.
we are selecting. This is again you have a VAV system, variable air volume system,
Yes, sir.
isn't it? You must have taken the VAV system. You have the dampers are there. That will accordingly give the sensors and it will actuate your BMS. Then it regulates your flow in the outdoor unit also.
Mm-hmm. But because
So what type of system?
earlier maybe I'm planning to offset
Uh-huh.
some of the sensible load by that outside air. Suppose I was
Yeah, okay.
supplying 500 CFM, but
Okay.
today the outside air requirement is just 100 CFM.
Okay.
So then the sensible load inside the zone
Yes.
that may, in some cases supersedes the capacity of the terminal unit. So, I face this kind of problem. Are we going to have a VAV system in detail in the next lecture?
Yes, yes. There is one class completely. VAV system one class is there. Even if you want, I can take tomorrow immediately in continuation of that one. A VAV, complete VAV system. I am talking in that again. I am talking about the ASHRAE standard also in that. I am referring this 90.1 in that also. In that. VAV
Maybe
system
we
is
can
there.
get a better answer there.
Yes, that's right.
Shubham, I'm sorry to disturb you, doctor. You're asking about the school. I think you are designing, and your doubt is pertaining to mainly school. Doctor has given me on the reference material regarding school, that is solar cooling and all, which I have already uploaded in the folder of sustainability lecture. So in your free time, you can go into that and study also that reference material pertaining to the school.
I understand. And, we will check. And I actually went through that. And this was just a question, but was not answered in that. Maybe in the future lectures where doctor will be, explaining the VAV in detail, we can get the answer.
Maybe that time we can link it in that.
Yeah,
Yes, that's
school
right.
is being more fluctuating kind of a load because sometimes
Yes, sir.
people are attending,
Correct.
sometimes they are into the lab, and so definitely the system is totally different than others. Your question was very much valid in that case.
And one more requisite to a doctor and Neeraj, that maybe you can put some more light and explain more about these kind of the chartered engineer, how to be a PE and those things, and what are the utility of those in future and how to go through those. So maybe that can be helpful. At least I'm interested.
Yeah, okay, that's good actually. I think many of the people are already, you have a chartered engineers. This is what you told when I asked the first beginning of my lecture. So
actually, Will said that we are trying, we're working on that path. Some of us are working.
Yeah, okay. That of course I can even send I will share in the reference material. I have actually the
Mainly
root of
about
that
the
one.
question, what I mean to say is, see, the PE is normally Canada and USA is recognized.
Yes.
So if you do the PE, they have a high chance of immigration and the value to the degree. So
Not just immigration, but yes, like that gives credential to the
No,
work.
credentials. This type of C engineering, you have so much professionals people. No, see, learning is a continuous process. Every stage and experience, practicing engineering comes only by experience. How when I still remember in 1985 when I was in somewhere near Chandigarh, in front of me the chilled water system and the ducting pipe in 2 years. Everything we studied in on paper academically. But when in front of me, when practically when I saw, then when I involved in the various type of process design, after 2 years, 87 or 88, when I returned back to my headquarters design. So when I had a different kind of decent project, as I told you, we have a DRDO, ordnance factories, supercomputing, fiber optic cables, even cold rooms, even comfort air conditioning, UPS, ADC, many projects. So every project when I do in the drawing board, when I am designing, every project has got me, matured me as a matured engineer. Every project has taught me a lot of lesson in that. Not only in the design, even various visiting at the site as various execution time. Then in front of your eyes, the project is coming up. Then you feel what you have put in the drawing. Then it is physically erected. And then during the testing time, commissioning time. Then after coming to Oman also for the last 20-25 years, not only the new project, even the refurbishment project, the old ones actually. This is all very challenging. It comes by experience. So the more the practice, the more you get more experience and the more challenging question. And everybody should not necessarily everybody should know the answer. And that is what these professional bodies normally share. Carrying they create the database. Whatever I have this one I put as a paper, and then that paper they take the data. And this type of professional bodies, that is very important. Whether ASHRAE or SEER or even AHRAE, all of these, they are doing a definitely wonderful job in that, and I just strongly recommend in that. I was a member for all this. I have done so much paper reading. On that basis only I have updated my skills in that. Yes, and if you don't update your skill, and then probably it is difficult. I have seen many in academic, most of the time what I have seen, if you see a electronics professor who graduated maybe 50 years ago, in electronics professor, he must have learned everything only on the vacuum tubes. Now, do we apply vacuum tube anywhere? No, the generation may not be knowing vacuum tube, isn't it? Even now, the computer science book, what I have written 93, that book, that is become obsolete now. Nothing is valid now. Because in the computer graphics, so much advancement, even computer architectural computer, something, everything has to change in that. So unless otherwise, if I update it, if I don't update it, then probably I will be lacking in that. So that is what these professional organizations always help you in that. And I will definitely share all this relevant chartered root status and everything to you in that. Even India, but only one point what I can say, this type of all these professional organizations, though they call us a trust, but they also need money. But in India, in that way, if you see the Institution of Engineers, they are doing wonderful job. Though it's a trust, but the government is giving so much support, and their charge is very, very less. I'm telling in India, the education system is so less, so cheap. And so many times I know probably hardly we spend any money, but education is so expensive. I mean, this professional bodies membership also. So that was the reason when now, when after my 60 years, I thought that, okay, I will now not renew, but still ASHRAE, they not allowed me. No, you have to be here in the membership. So they forcefully asked me to renew my membership last year actually in that. Otherwise, I told them now I will be leaving actually, but they told me no, you should continue in that.
Sir, I got their concern. We'll discuss separately how we can answer
Yes.
that question in this coming few days, and we will try to accommodate that in our coming sessions. I understood what they need, so we'll
Thank you.
discuss it separately.
Thank you, sir. Thank you very much.
Any questions for the Team Pinnacle?
I guess no, sir. I've asked my colleagues, and yes, they have their answers.
Thank you. Do you want to come tomorrow or
No, sir.
Tuesday?
No. They have already spoken to me, sir. No.
Okay, that's right. Okay, thank you.
First of all, yeah, I wish to add it one more thing.
Yes.
The leg one of our session is part one of our session. This week is over, and next week we are entering into the next week now. Firstly, I am very much delighted to see the Team Pinnacle here because the topics they have chosen, they could have easily chosen the topic like design management and the project management, which are much more general and romantic as compared to the other technical topics. But they have given preference to the technical topics, and which is not at all romantic. Sometimes we feel boring, but still they have chosen these topics, and I very much like this approach of the engineers and the management also promoting them and encouraging them to be the more aware on the technical things. So keep it up, and we are there with you. Let us enjoy the leg two even more.
Thank you, Mr. Neeraj, and thank you all my engineers, and all the best, and have a nice weekend. Thank you very much.
Thank you, sir. Thank you,
Thank you.
Ramaswamy, sir.
Thank
Thank
you,
you, Neeraj.
Thank you very much. Thank you. God bless you all. Thank you.
Thank you, sir.